Okay, this is a site in South Wales, and we've had a part of the design involves completing a half circle of 3 meters 832 radius and taking it up 6 meters in height. A complex sort of thing to do, really. You wouldn't do it simply without having some specialist shuttering system. So we tried ringing around a few people, and the one we come up with was supplied by a guy called Phil Mantle from RMD, and he came down to the site and he demonstrated how to use it, bringing 2 guys with him. What we learned from the demonstration was that if you cut any corners, it'll really come back to bite you in the teeth. It's not the thing to adjust. Once you've set these shutters in, effectively what you do, you set them to a former, right? What that means is you get a sheet of ply and you mark out what you're aiming to achieve as the curved profile on the sheet of ply, and then you offer the sheet of ply up to the shutter, and then you use these adjustment sections that are on the shutter, and you pull them in together by means of this point here, and as you pull them in, the shutter curves. So the movement is done by this little item here, adjusting this by my feet, and that effectively gets the shape to match the sheet of ply. A 2.4 meter sheet of ply is needed because you need the whole length to cut the former, because the shutter is nearly 2.4 meters long. So once you've made these sections of shutter that make up your circle, on this site here we've got 4 of them that make up the half circle. So if you're doing a full circle, you'd need 8. And I'm sure the way the design works, yeah, it depends on the radius, obviously. Right, so once you bring the shutter over by a crane or a machine or whatever it is, we've just used a 360 excavator here. You put it in to a line of hilties on the bottom, and then you use these push and pulls to get the shutter to its alignment. And alright, just recording it there. I'm on your. It's come out quite well. Do you want to have a look? We're looking for 2 meters. I might well have. I think I left it under the drawing.
I remember.
It's just got to say I'm guilty. I'm notorious for doing it. I don't do it intentionally. I don't think so. It could be in my office.
I know you were drawing on that drawing with a red pen, and you just plug it off. I thought, where'd you gone? I was looking for a drawing.
Yeah. Oh, okay. There we are. That's your red pen.
That's it.
Sorry. Right. What we're looking for is I got the laser now on the bottom of the first push pull. Okay. And we're looking for a distance of 2812, which is 2832 less 20 mil. So I'm looking there for a distance of 2812. I got 2809, that's 3 mil out. Just check the plumb. We've set it with a chippy, so we know it's quite good. And we've taken a reading up the top of that first push pull, and we got 2813. So say 2813?
Yeah.
So we're doing the next one now. We start off at the bottom again. The bottoms have been set by using a metal tape, so they shouldn't be far out. Spotting it where the laser is the battle now. Right, so taking another reading at the bottom, and we got 2810, so that's within 2 mil.
Yeah.
And we're taking a reading at the top for that next, so just go in a little bit. 2810 again, so that's perfectly plumb within 2 mil. It's quite smart, isn't it?
Yeah.
Right, so that's the first shutter. Once you set the first shutter, the second shutter goes in, and it only needs 1 push pull at the end of the section. So it's already been curved to the right radius. So we're taking the reading at the top of that, and we got 2805, which is 7 mil out. We'll be checking these after this being concreted, which will happen in about half an hour. We're checking the bottom of the second section, and we got 2812, which is the correct dimension. So we're going out to the third section, the third of the 4 sections, and the reading on the bottom is 2815, which is within 3 mil. take a reading up to the top with a laser, and that reading is 2810, which is within 2 mil. So just to show a close-up of where the laser is, that's just on the back of the shutter there, and you can see it's very close to where the push-pull acts. So taking our last reading next. Reading is 2 meters 824 on the bottom.
Well,
yeah, and on the top it's 2812. What has happened here is the bottom was right earlier, and we adjusted the top 12 mil. What we didn't do is go back to the bottom to check the bottom. So I'll just get a chippy to pull the bottom back 10 mil. I can actually do that myself. It's quite straightforward. Right. The adjustment by here, so we want to come back 12 mil. That's forward. That's a look. Yeah, we get a chippy. I don't want to be responsible for opening these shutters and getting it wrong. Reading at the bottom, 2825. Yeah, the shuttering system is pretty impressive. It works very efficiently, very quickly. You can lift a half circle like this in with 2 chippies in a day. You can easily align everything up on it. So just getting the chipping out all to the bottom. We have just a slight movement on the bottom here. That's John.
Huh?
Can we have a quick check on the bottom over there? It's gone out by 12 mil. We got the top right. The bottom wants to come this way 12 mil. It's probably have a problem with that now because we've got wedges on the bottom of it. Yeah? What's that? No. As soon as the concrete comes, I'm going to disappear. Alright, okay. 2 minutes then. It's got to come back about 12 mil. We might have that wedge as a problem, right?
Because the lad's upside down.
He's alright, he has, is he? Well noticed, Brian. That's strange, that is, because I was bang on earlier. You moving?
Come to the end of the last week. What does that need to do?
Oh, it needs to go to the next notch, does it?
Yeah. Real reach. push it in it.
Yeah. I can see that move. Okay. 2813, that's right on the bottom now. Just check him on the top. And right on the top, yeah, fine, that's okay. Right, that's stable now, or do we need to